We are solving polynomials in factored form. A polynomial is in factored form when it is written as a product of factors. Up until now, we've been dealing with factored form to FOIL to change it to standard form. We want to keep it in factored form. So here are some examples here. And we want to solve these. And we're going to use something called the zero product property. And we're going to use these to find roots. We're going to use the zero product property, and this tells us if the product of two real numbers is 0, then at least one of the numbers is a 0. Algebraically, if a and b are real numbers and a times b equals 0, then we know either a or the b has to be 0. If we had a problem where it was 5a equals 0, we would know that a would have to be 0 because the product is 0. If I have the problem x times the quantity x plus 8 equals 0, I know that one of them has to be 0. Either the x is 0 or the x plus 8 equals 0, because the product is 0, so one of them has to equal 0. Either the x is 0 or x plus 8 equals 0. My solution for this then would be x equals 0, or in this case I want to solve for x, so I would subtract 8 from both sides, and my solution here would be x equals negative 8. So my two solutions are either 0 or negative 8. For this problem, I have the quantity x minus 6 times the quantity x plus 5 equals 0. I know that either this has to be a 0 or this has to be 0, so I'm going to set it up so one of them is 0. X minus 6 equals 0, or x plus 5 equals 0. When I do this, I just solve them both for x. In this case, add 6. So my solution could be x equals 6. And in this one, subtract 5. So x could be negative 5. So my solution for this would be negative 5 or 6. For this problem, 3t times the quantity t plus 2, I set them up so either 3t is 0 or t plus 2 is 0. If 3t equals 0 or t plus 2 equals 0, I solve them both for t. In this case, t equals 0, or subtract 2, t equals negative 2. My solution would be 0, negative 2. One more example to solve 2a plus 7 times the quantity 2a minus 7. One of them has to be 0, so I set them both up. 2a plus 7 equals 0, or 2a minus 7 equals 0. I solve them both for a. In this case, subtract 7. So 2a equals negative 7. Divide by 2. So a could be negative 7 halves. On the other side, I add 7. 2a equals 7. Divide by 2. So a could be a positive 7 halves. And those are my two roots.